Hello everyone, my name is Mauro Kleider. I'm a senior manager with Amazon Redshift. I've been with the service for the last 6 years leading Redshift product and database engineering teams to develop our product and delight our customers. I'm very excited to share how we have evolved Amazon Redshift to support large-scale analytics for our customers. And together with me today, we have Ryan Wilkie, a solution architect with Amazon.com, one of our largest customers, who will share their journey with Amazon Redshift. We'll start by talking about data analytics at scale and what it really means to our customers, and then describe how the architecture of Amazon Redshift has evolved to support customer needs. Ryan is then going to present Amazon.com's experience with Redshift and focus on their usage of RA3, our most recent node type, their current use cases, and future plans. Let's get started. We hear from our customers all the time that they are looking to extract more value from their data but struggle to capture, store, and analyze all data generated by today's modern and digital businesses. Data is growing exponentially, coming from new sources such as IoT devices and from social and mobile channels. Data needs to be securely accessed and analyzed by any number of applications and people, and it is getting increasingly diverse. Trying to capture and make sense of this data has often left customers with slow performance, systems that are difficult to manage, and that are hard to scale. We also know that costs can increase quickly with some data warehouses, while not fully delivering the value that customers need. It can be difficult to know what to expect and to keep up with the growth of data, users, and use cases. That's exactly why tens of thousands of customers are using Amazon Redshift, and it is the most widely used cloud data warehouse. With Amazon Redshift, you can analyze all of your data and get fast performance at any scale with low and predictable costs. We take a lakehouse approach to analytics with Amazon Redshift, enabling you to query all of your data in the data warehouse, in your data lake, in your operational stores, using the same tools and familiar SQL. You can also save your data to the lake and access it with other services and tools such as Amazon Athena, Amazon EMR, and Amazon SageMaker. Redshift enables you to gain valuable insights and focus on your data, and not have to manage your data warehouse. Being a fully managed service, Redshift takes care of performance tuning, software upgrades, backups, and more so you can focus on your analytics. Redshift provides fast performance at any scale. RA3 nodes with managed storage deliver up to 3x better price performance than any other cloud data warehouse. Redshift is built for the new scale of data with features like Aqua, a new hardware accelerated cache that boosts queries up to 10x faster than any other cloud data warehouse. Unlike other cloud data warehouses where you need premium versions for additional enterprise capabilities and you need to pay extra for those, Redshift's pricing includes all the features you need, including built-in security and compliance at no additional cost. I'd like to walk you through how Redshift architecture has evolved over the last several years and demonstrate the fast pace of innovation that supports some of the most demanding and mission-critical analytic workloads. First, Redshift was launched in 2013 as a fully managed cloud data warehouse, being 10x faster, 10x cheaper, and much easier to use than any other solution. In 2017, we launched Redshift Spectrum, a massively scalable compute layer that enables any Redshift cluster to query all data out to exabytes in open file formats directly in Amazon S3. This enables our customers like Yelp to query all of their data with minimal time to insight. As more users started to use Redshift, we added the ability to scale cluster resources to accommodate thousands of concurrent users and queries with predictable and fast performance. This enables customers like Fox to meet demanding reporting SLAs. As more users brought more data, we separated storage from compute and enabled customers to ingest tens of petabytes to their Redshift managed storage and query it with our latest and fastest node type, RA3. We have also developed Aqua, our proprietary query acceleration layer with computational cache, to provide fast performance at scale. RA3, Redshift Managed Storage, and Aqua are the scalable building blocks that will support upcoming features, including data sharing, which enables cross-team collaboration with multiple clusters accessing live data in the Redshift Managed Storage layer. let's talk about each of these features in more details. Array3 nodes are built on the AWS Nitro system and feature high bandwidth networking and high performance SSDs as local cache. The Array3 nodes leverage your workload patterns and advanced data management techniques to deliver the performance of local SSDs while scaling storage automatically to S3. You can scale and pay for compute and storage independently, allowing you to size your cluster based only on your compute needs, and you pay accordingly. In case you haven't had a chance to evaluate Array3, you can create a cluster with Array3 nodes or upgrade your existing Redshift cluster to Array3 via the AWS Management Console within a few clicks. Array3 compute nodes come in 3 sizes, offering customers more granularity in controlling performance and cost. You can start for about $1 per node per hour and scale as you go to tens of petabytes of data with each cluster and pay only for what you use, both in terms of compute and storage. Now, reserved instances discount provide up to 60% price reduction for workloads that you run in the coming years. That's super exciting. Now, what even more exciting is that Redshift is the fastest cloud data warehouse, providing up to 3x better price performance than any other cloud data warehouse. This means a lot to our customers. And Redshift scales really well all the way from terabytes to petabytes, providing customers with predictable performance and cost. Our customers double the amount of data they analyze on average every year. This means that if you start with 1 terabyte, you look at petabytes of data in the coming decade. And as you can see in the chart based on TPCDS runtime, Redshift scales really well in terms of query execution time and normalized cost per terabyte to fit your needs as you grow your usage. And this is really important consideration when you're making a decision regarding your data warehouse that is likely to serve you in the coming 5 to 10 years. The next innovation that expands Redshift's fast performance and large scale is concurrency scaling. This feature automatically adds and removes capacity to handle unpredictable demand from thousands of concurrent users and queries. Customers can plan their budget with cost controls, enabling them to define usage limits and monitor usage on a daily, weekly, and monthly basis. To enable concurrency scaling, all you need to do is to simply set the concurrency scaling mode to auto in the AWS Management Console, and from that moment on, Amazon Redshift can take care of any workload peak from your end users automatically and transparently. Another exciting feature that we just announced is the Amazon Redshift data sharing in preview. This feature enables you to share data across your organization and with external parties to enable a broad array of new use cases. Now, customers have a simple and direct way to share live data across Redshift clusters without making copies or dealing with the complexity of moving data around. This makes it easy to collaborate across teams and instantly query the most up-to-date data in the Redshift managed storage layer for different use cases. For example, you can share data across development, testing, and production environments and deliver data as a service to external partners and more. Data sharing enables secure and governed collaboration because you can set permissions at the granular level and easily track and manage access across your Amazon Redshift clusters and AWS accounts. The last feature I want to talk about before handing it over to Ryan is Redshift's native support for semi-structured data, which enables you to store, ingest, and query nested data directly in Redshift. This enables our customers to extend their usage of Redshift to query nested data as part of many use cases, for example, operational analytic use cases, in which data can be ingested to Redshift in its new raw format of nested data directly coming from various applications. This is based on the super data type that can be queried through an easy-to-use SQL extension that is powered by the open source Particle language. The Particle language is a SQL-compatible query language that makes it easy to efficiently query data regardless of where or in what format it is stored. And as you can see in the example here on this slide where we want to get the cell phone number of Jane, we're using an intuitive SQL to a nest and array that is stored locally in Amazon Redshift as a super data type. Ryan will take it from here to talk about how Amazon.com powers their large-scale analytics with Amazon Redshift.
Thank you, Mayor. As he's mentioned, I'm a solutions architect for business data technologies with Amazon.com organization and an evangelist for the bleeding edge analytics technology that Amazon Redshift offers for our large-scale needs. Amazon.com is well known to provide customers with a seamless end-to-end customer transaction experience. To provide this experience, there are many complex tools and systems in place along the pipeline. This pipeline of systems generates petabytes of data, which is routinely collected and analyzed. This is a prime large-scale analytics example where Amazon.com would greatly benefit from AWS analytics tooling. The Business Data Technologies organization, of which I serve, exists to serve Amazon.com's growing analytics needs, and its mission statement is accelerate business insights and data-driven innovation by providing secure, compliant, reliable, intuitive, and cost-efficient technologies that our customers trust. The Business Data Technology organization serves a variety of users and use cases in Amazon.com, from business intelligence engineers to group program managers, from ad hoc analyses to quarterly and annual reports for organizational VPs. We have over 38,000 active data sets of curated business data amounting to over 500 petabytes in the data lake. Nearly 1 million daily ETL jobs actively pulling against the business data. Over 80,000 active users on our platform. And today, multiple thousands of Amazon Redshift instances. In 2016 to 2017, the Amazon.com organization established a synergistic relationship with the Amazon Redshift organization to help realize an analytics technology suitable for any scale. Multi-node data distribution and processing power would become a paradigm shift for Amazon.com analytics and its users. Between 2017 and 2019, Amazon Redshift analytics technology has allowed Amazon.com to migrate from a centralized legacy technology-based data warehouse to a decentralized compute and data lake pairing. The onboarding of Redshift Spectrum encouraged a mass adoption of Amazon Redshift by our internal customers for users who wanted to be able to consume specific partitions and no longer need to store the data locally. In 2020, Amazon.com embraced RA3 nodes to provide performance and cost-effective scalability for Amazon.com. This allows Amazon.com to leverage the latest Redshift features, including data sharing, the super data type, materialized views, and Aqua. Next, we're going to dive into the data lake architecture. Migrating to a centralized data lake model with AWS tooling would allow for the Amazon.com organization to scale. Let's walk through how we designed our data lake and how Amazon Redshift powers Amazon.com's large-scale analytics architecture. With data being processed by our customers with the amazing performance of Amazon Redshift, this allows for Amazon.com analytics to leverage a centralized data lake model with AWS tooling to scale both in terms of data storage savings as well as performance optimization. We call this our Andes data lake. By decoupling storage and compute logically and utilizing a subscription-based consumption model, we were able to serve more customers at a larger scale. This is in large part thanks to Amazon Redshift. Amazon.com's Andes data lake architecture utilizes a data producers and a data consumers model, where the primary method of consuming and analyzing the available data is through Amazon Redshift. Andes Data Lake is a product of both AWS services and in-house development, utilizing S3, DynamoDB, Swift, alongside a custom data subscription service. Data files are loaded into S3 by the data producers with custom ETL processes into the Andes data lake. The subscription service allows consumers to pull data from the Andes data lake and synchronize the data into Amazon Redshift instances with custom synchronizers. Amazon Redshift can push, pull data from Andes data lake, allowing consumers to also become producers. Spectrum on Amazon Redshift allows for customers to leverage the glue catalog on top of the Andes data lake for when local storage is not an efficient use of time and cost. Analytics data outputs using Amazon Redshift are integrated into the Amazon.com organization's reporting systems and system applications for various stakeholders, including external customers. Examples of how producers and consumers coordinate with the data lake and utilize Redshift to produce analytics that the end user will experience. The Amazon Prime accounts produce membership data that is pushed into the Andes data lake and is synchronized to the consumer's Prime Video. Prime Video can now determine which accounts have memberships and therefore can utilize Prime Video. Redshift Analytics enables Prime Video to make this determination. Pipelines consume this output data and push it to the external customer. Another example is the Amazon shipping organization produces shipping data that is pushed into the Andes data lake and is synchronized to the consumer's Amazon Alexa devices. Amazon Alexa is now able to alert the Alexa devices from the shipping data analytics for when an order is delivered. Redshift Analytics enables Amazon Shipping org to map a delivery to an Alexa device. Pipelines consume this output and push to the external customer. To determine how Amazon.com analytics needs to evolve, its challenges first need to be identified. And what we've seen is as data scales, technology performance improvements should also scale. We see that customers want the ability to scale their data storage needs without over-provisioning compute capacity. This means having a solution that's scalable and cost-effective and is able to reduce intensive load operations on individual instances with fewer duplicate ETL pipelines. Amazon.com users ultimately desire better query performance and reduction in costs to operate. We see this potential with the new RA3 node type. BDT performed a proof of concept comparing a real-world RA3 Redshift node type performance metrics against existing DS2 production Redshift metrics. Based on the findings of the proof of concept, we recommend internal customers upgrade to the RA3 instance type. Improvements include a 30% decrease in real-world job run times for most ETL workloads. Storage costs are separate from compute costs, which fundamentally allow for better budget planning, and offers a way of cold storing data that is infrequently accessed. RA3 on demand will cost the same as DS2 on demand by performance measure. Also, RA3 nodes have twice the amount of horsepower and nearly unlimited storage capacity. Most notably, there was a 30% decrease in real-world transform job runtimes and a 45% decrease in table load runtimes. By switching to the RA3 instance type from DS2 with similar on-demand costs, we would see an overall benefit in runtime performance for ETL-intensive pipelines. Amazon.com is currently able to leverage the recently released feature, Materialize Views, on all of its existing Redshift clusters. And this has allowed us to return results much more quickly for repetitive, predictable table queries. This is currently generally available and our customers love it. There are also fourth quarter 2020 RA3 feature releases that Amazon.com greatly anticipates. These include Aqua, paired with Nitro, which will allow for faster S3 managed storage reads to and from the Amazon Redshift instances. Customers would greatly benefit from increased read and write performance with this. Data sharing is seen within Amazon.com as a potential game changer and is currently being benchmarked against production loads. This will allow for teams to create their own data share curation and read instances so that multiple local copies are not necessary for the Andes data lake. This has the potential to increase performance as well as save on costs. Additionally, there's the super data type that will be released. And currently we have multiple tools to perform the same action that the super data type offers. This simplifies data pipelines for JSON data ingestion and will help further our development as an organization. Amazon.com is very excited to see what other amazing features we can look forward to in 2021 and beyond from the AWS Redshift product. That concludes the story of the relationship with Amazon.com and Redshift. Back to you, Mayor.
Thank you, Ryan, for sharing your inspiring journey with Amazon Redshift, and to all of you for joining our session. If you're already using Amazon Redshift, I encourage you to continue to learn more about what's new and make sure that you are taking advantage of the latest features in Amazon Redshift. Check with your account team for a free architecture optimization session that we're happy to conduct for you. If you're just getting started with Amazon Redshift, I encourage you to ask your account team for a 10-minute demo and refer to our website and documentation to learn more about Amazon Redshift and how to start a proof of concept. Our team is here to support you, and you can always request help from the AWS team using the link on the bottom of the screen. Thank you for joining our session today and enjoying the rest of your re:Invent sessions.